Hello everyone and welcome to this video illustration. In today's video we're going to be looking at an AI that can solve the Knights and Knaves puzzle. If you're not familiar with this puzzle, let me give you a quick rundown. This puzzle, you are given a number of characters, any number of characters, and each of them has a statement. And the trick here is that each of those characters is either a knight or a knave, where a knight will always tell the truth, so any statement said by a knight is true, and the knave will always tell a lie. And you need to use your logic to determine which of those statements is false, to determine who is the knight and who is the knave. And in this assignment, I'm going to be attempting to solve those four puzzles here. So the trick here is just representing the logic using propositional statements and propositional logic to the AI so it can solve it using model checking. So if we go quickly through the files here, we have two files, logic.py and puzzles.py. Logic.py, we define the classes that holds all of our propositional connectives and symbols, and a function down here that does the model checking. And that's pretty much it. As for the inside puzzle, now inside puzzle we represent each of those four puzzles to the AI and then attempt to solve it using model checking. And in order to do this successfully, we need to represent the game's logic along with the statement's logic. So the game logic would be something like this. So if we go to the top of the file, we'll see that I've defined here the game logic for each character, where I'm just explicitly using an explicit or telling the game its logic. So I'm basically saying that A is either a knight or a knave, but not both. So it's a knight or a knave, but not a knight and a knave. It has to be one of the two, but not both. And the same applies for character B and C. And then as for our statements logic, we'll be representing whatever the characters say in a biconditional statement. Let it load here in a biconditional statement so that we can evaluate it. So for example here, using the game's logic and the power of the biconditionals, I will just state whatever the character said, and if it's true, so if this statement returns true, then I'll say he's a knight, since if it's true then he's telling the truth. And since it's a biconditional statement, it's if and only if. So character A is a knight if and only if this statement is true. And since it's not true, and since our system already knows that it has to be one of those two, it cannot be none, so it will conclude that it's a knave. And to give you an example here, in the first puzzle, character A says I'm both a knight and a knave. So we represent it by saying that he's a knave and he's a knight, and if that's true, which is not, then he's a knight. And if we run the code here to see the results of all the puzzles, we'll see what. Okay, here we go. So we'll see that A is a knave, and then for the second, let's look at puzzle number 2 here, which is the third puzzle, for an interesting part. So here we say that likewise we constructed a biconditional statement and gave in whatever the character said for both of them. And we stated that if this statement is true, then A is a knight, and if the B statement is true, then B is a knight. But if we look here, we'll see that A is a knave. And while we didn't directly state any condition to declare that A is a knave, using the power of biconditional, the system was able to logic through it itself and conclude by the game's logic and by the given statement that A declared that this statement is false. And since its logic says that it either has to be one of the two and it's not the knight, then we conclude that A is a knave. That's all for this video. Thank you so much for watching and have a nice day.